Right, good morning. 8.4 Algebra of functions. Operations between functions is our topic. There are 5 operations you can do between two functions. 5. What you see on the picture is 4. Addition, subtraction, multiplication, and division. Just like numbers, you add, subtract, divide two numbers, right? You can do the same for between functions, okay? The 5th one is not on this page, it's coming up later. It's called composition. It's not technically an algebra of functions, it's composition of functions, that's what we call it. It's a little bit more challenging and different. You probably never seen anything like that, okay? Alright, so we have a separate moment for that part. Why don't we first learn how we add, subtract, divide, multiply functions first. It's very simple. You copy the formula of the first function, copy the second formula of the second function. They will both be provided to you. And just put the sign in between those two formulas, expressions. This is the division symbol, by the way. Okay? Fraction or division symbol. And you perform some simplification operations afterwards, like adding like terms. If there are numbers together, add those numbers, or subtract numbers, multiply numbers. If there are same power axis, x squared, you add them. We call them like terms. So you combine like terms. Okay? That's pretty much it. So the first half of the session is pretty easy, straightforward. The second half, not so much. So pay attention, alright? So there are 3 questions, similar type questions we will start with in our homework. The first one is, what symbol do you see between the functions? Look at it. Plus. We are going to do addition. So basically, you copy the formula of f, copy the formula of g, which are given on the right side of them. Copy these and put the plus sign in between. Again, f plus h o x will be formula of f, formula of, not gh, and the formula of f is, go read it, which is x plus 6, and then the formula of h is, what is it, x squared plus 3. And what do I put in between? Plus sign. Okay? Next, are we gonna just leave our terms like this? No. Please add up like terms. That's must. You must do it. And optionally, we like doing this. Reorder terms from biggest power to smallest power. So search the biggest power term here, x squared. Do you have anything like x squared so we can add up? No, right? We don't have any more x squares. So I put it right here without any change, no addition. Next, what is the next high power term? It's x to the first power, x only. It has no power. It has no other x like it. So we just copy it here. And finally, there are 2 numbers. They are like, as default, numbers are like. So we need to add them up, which is 6 plus 3, which is 9. Right? That's it. This is all you gotta do. You have successfully added 2 functions. Any questions? Yeah. It seems very smooth. Oops, not that. But no, there are danger spots coming up with the other operations. Addition is usually smooth like this. Addition is simple. The next one coming up has a sign. What is this sign? A subtraction sign. So what is different now? Well, you find out my mistake. Alright? So it says, the formula says, just separate these up, f and g with their own axis, and put a minus sign in between. Yeah, that's what the formula says. If you see f minus g, separate up and put a minus in between. Okay, I did that. Next, as usual, I will read. Only you need to do is read their definitions. G is, where is G? Read it. Read its formula, minus 3x squared plus 5x. Now read f of x, please. Where is f of x? There you go. It's x plus 3. Correct? Correct? Any issues so far? And what do you see in between these things? Minus sign, a subtraction. So I will just put that minus sign like that. Like that. Alright. Any issues so far?
Shouldn't F and G be switched?
No. No, we don't switch them because you use the order given in the question. Okay. This is G's first, F is next, so order matters. G is first, F next. No, I don't have to switch them. Yeah, in the formula they put F first, G is next because I see F first, G next. Okay? So order is the same as in the question. So no mistake there. There's somewhere a mistake. Anyone? Where is the mistake? If you say no mistake, I will continue.
You have to distribute the negative to the x plus 3.
Right. We are subtracting. This is subtraction. 2 items from a pile of other items. 2 items. So, but when you put the minus only in front of the first item, that means it looks like you're only subtracting x but adding another item plus 3. So when you have a function with more than 1 terms, this is 2 terms, more than 1, you need to keep it in parentheses and distribute out this minus to not only first one but second term. Both terms must get that minus. So the correct expansion should not be just minus x, but also minus times positive 3 is minus 3. The second one should be flipped. So in other words, you need to flip all the signs in the second function coming up. All the signs. So x becomes minus x, positive 3 becomes minus 3. Got it? That's only true in subtraction. We don't have to worry about that in addition, because if you pass plus sign to both terms, it does nothing. Right? X squared is plus x squared, 3 is plus 3, so you still just have the same thing. We only do that for minuses. Are we done though? Is this over? There are like terms here, right? These two are like, so we can combine them. They make 4 of them. 5 take away 1 is 4. And this is our final result. Okay? Alright, we have a multiplication coming up next. I need to know those two functions to multiply. Again, g dot f means this is multiplication. You put the formula of g, you put the formula of f, and just multiply. Okay, there are mistakes, possible mistakes waiting for us here. First, we copy their formulas as usual, right? Here and there they are. G is, what is G? 2x squared plus 4x. F is x plus 5. And, oh, I see a dot in between, so I will put a dot between only 4x and x. Is that right? and we get, this is the same, 2x squared. 4x and one more x makes, x times x makes x squared, right? This thing is x squared, correct? And 5, we add these up, we get 6x squared, because they are like, and 5. That's it. You guys agree? This is wrong, false. Even Connect Math will say it's wrong. I wonder where my mistake is. Where did I mess up? Shouldn't be that easy. Look, wrong. Where's my mistake? Again, mistakes happen. Yeah?
You can't add 2x squared or 2x squared and 4x.
This is 4x squared. They are like. They are the same. They have the same power. 2x squared and 4x squared. I multiplied these two. I did multiply these two. 4x times x makes 4x squared, right? 4x and one more x. This is double x makes 4x squared.
Why don't you have to use the FOIL method instead?
Right. The mistakes in multiplication and subtraction are similar. When you add, when you change these formulas, G and F, by multiple terms, this is 2 terms. And this one also multiple term. It's not a single term. It's 2 terms in each case. You need to put parentheses around them and multiply and distribute it. So it's 2 term versus 2 term multiplication. It's a FOIL, perfect FOIL. So you need to distribute this as first terms, outside terms, inside terms, last term method. FOIL. Okay? So 2x squared times x makes 2x cubed. Outside terms, 2x squared times 5, 10x squared. Inside terms, 4x times x is 4x squared. And last terms is 4x times 5, which is 20x. Are there any like terms we can combine? Right in the middle. These two are like. The other two are not. So we will copy the other two except the middle. We will add the middle terms to 14 of them. And there we go. Thank you. What was the last one? 20x. That's it. Now we're corrected. Alright, guess what the last operation example is? A division. Maybe this is the easiest one. All you need to do is divide f by h. It says, right, f divide h. You need to copy the formula of the f to the top, formula of the h to the bottom. What do you read for f from the formula? X plus 8. What do you read for h? X squared plus 8. But sometimes you guys make a question harder than it is, it seems. Such as this one. Oh, I see 8 and 8 common. I can cancel them. I see one of the x's and one of the x here cancels, and there is only one x remaining here. So it's nothing on the top, so it's 1 over x, the result. Is that right? Everything I did in the last part is incorrect. Everything. They're all incorrect because you cannot cross out eights because they are adding to other items. Addition, if the number or term you're canceling is adding up to other stuff, you cannot cancel them. The correct operation must be multiplication. If it was 8 times x, yes, you could. But now this is x, 8 plus x, we can't cancel them. Same way, we cannot cancel these x's because they are adding up to other items. Addition is kinda bad operation for cancellations in numerator. So the final result is just this entire thing. There is no reduction, cancellations. Okay. All right. Second, what is ask here? It's asking for restricted values. This is way back to when we did quotients in chapter 7. Restricted values are the values you enter into the function. Let me clean this up. So your final result is this: x plus 8, x squared plus 8, right? Are there any values, we call them restricted values, when you enter into x, it's gonna make this thing undefined. So when do ratios becomes undefined, such as this? What's wrong with all these 3 examples? Why are they undefined? Perfect. 0 in the denominator is something uncomputable. We cannot divide a number by a 0. So my question is, are there any values you substitute into x, square it, add 8, and this is gonna be 0? How about negative 8? Negative 8 plus 8 is 0, right? This is as a square. When I enter negative 8, it's gonna make it positive 64. Nope, not negative 8. Can you try more values? Yeah, you know?
Well, I mean, no, because anything you square is going to be positive.
Right. Well, no matter what you try here, when you square it, it's going to be positive. Positive means something more than 0. If you add something more than 0, it will be even bigger than 0. It will be even more. So how can you expect it to be exactly 0? Impossible. Okay? So even you try to solve this, you see that x squared becomes negative. No number once squared becomes negative 8. So no restricted values. Here we have no restrictions. Okay? That was just a review of something we know from the past. This is has nothing to do with the new section. Okay? Alright, here comes the difficult part. Fun is over. By the way, any questions about the first 4 questions we solved? 4 operations: addition, subtraction, multiplication, division. Just because we passed this quick doesn't mean it's safe and secure. Again, watch for subtraction, multiplication. Use parentheses if you have multiple terms multiplying, and distribute. And use parentheses again if you're subtracting something with multiple terms. Pay attention to those 2 questions. And practice more. Hit the practice button in the homework to check more questions out there. But I want to emphasize this because this part is most confused. Composition of functions. And what is the notation first? How do I know I need to be composing, not multiplying and dividing? This is the notation. Do you see that? What is it? Is it a dot? You're far from it, but do you see that? It's a circle. There's a little circle there. That means compose. Some people think, oh, this is a multiplication. No, this is not filled in. This is multiplication now. Now it's not. Okay? Do you see the difference? For example, in this question, you're going to not multiply, compose. Okay? For this question, you are composing. For this question, compose. Not compose, but compose. And that's it. So anyhow. Or sometimes they give you directly this. This means compose as well. How do I know it's composed? Look, F, I call this a belly of F. This parentheses belong to F guy. This is F. Inside the belly of F, there is another function living in. Like a parasite in your stomach. It's living, it has its own family there. Okay, G of X. Inside F. That means composing. Alright? So how do I know again? Watch for parentheses, multiple parentheses. If you see one set of parentheses and a letter outside, that's one function. But under it, if you see another parentheses with its own function notation, that means it's composition. These two talk the same language mathematically. G is inside F, G is inside F. So whoever is first, that's outside the main function. The other one is inside the belly, parasite, okay? Alright? So I will show you how this works with machines, of course. This time I'm going to use a real life example. Functions are like buses. I gave you bus examples. It takes passengers to one stop and then another bus picks you up and go to another destination. So this is kind of two bus travel. This is you guys. This is the passenger. First riding in bus going into a city, and afterwards, immediately afterwards, another bus picks you up from that city and takes into another city. You can think like that. Again, passenger is moving with bus for, G, and then taking it, once you're out of bus G, you take another bus F. That's one example I can associate with. Or another example is machines. Let's say this is wheat. A bushel of wheat, let's say. You supply it into machine. This is your machine. What kind of machine is this? This is a grinding machine. What happens if you grind wheat? What do you get? Yeah, you get flour. So this is G is a grinding machine. You get flour, and this flour is supplied into another machine. Guess what kind of machine the second one is? What do you do with flour usually? Throw each other? No. What do you do with flour? You bake things, right? So this is a bread machine. So somebody, a factory worker, is putting wheat into a grinding machine and then picking up the flour and supplying into another machine, another worker. This is multiple steps. I want to combine two machines into one and build a combined, composed machine. Composition is combining two machines, building one inside another one. Look, one inside built in another one. Outside you don't see two machines. You see one machine. You put flour in one side and the other side gives you a hot fresh bread directly. You don't see the grinding and moving into bread machine. Everything is done automatically. So composing functions means getting two machines, building it one inside another one. Okay? So these are two examples. Either think it as buses, chain of bus travel, or again, flour is traveling to, wheat is traveling to flour, flour is traveling to bread, kinda with machines. Same idea. Or you can even put into your reasoning, okay? You can make your own examples. Alright, but how do we do this mathematically? When somebody give us two machines, look, this is the grinding, which one is grinding machine? Whichever one is inside, this is grinding machine. This is the bread machine. The one in the, how do I know this is bread, this is grinding? Because the one in the outside is always the second machine. Here's the first one. This is grinding one. Flour is gonna be ground by G, and then the flour will be taken to the bread machine F next. And this is exactly what's going on. You take X and send it to G and check out the result. What happens if X goes to G? It's set here. This is what happens when X is processed by G. Look, X is really in the belly of G. It's processed into this. X turns into X plus 5. Kinda you have 1 bushel of flour turns into 1 plus 5, 6 bushel of flour. It's impossible, but I just made it up. Okay, so this machine is increasing your quantity by 5. That's what it does. It says so. And then you take that X plus 5, put it here, and send it into second machine. But the second machine formula is given by X's only. If I see X, this is X, but I don't see X here. I see X plus 5. So what I do is I'm converting all these X's into X plus 5. So whatever you see in parentheses, you make that conversion. You convert the original formula X into that term in the parentheses, X plus 5. Again, for those who doesn't want like the stories, this is what you do. You copy given formula for this one and put it right here. What is given formula for g of x? X plus 5, right? Okay. Next, you copy the given formula for f here, except every x removed and replaced by this term. Look, x plus 5 made there. Can you all see that? Instead of 2x minus 3, I have 2 parentheses open, x plus 5 minus 3. Then you distribute this, simplify. Rest is simplify, add like terms, etc. So you're kinda combining 2 machines into one. This is the state of the art combined bread machine. You supply wheat and get the bread out quickly without using 2 separate machines. This is a united, combined, one package machine. Look, it's a lot simpler. 2x plus 7. Instead of using 2 formulas, twice the work, 2 workers, you do it one assembly in one line. That's it. Okay? So let's do our examples. I want you to first try this on your own in 2 minutes. Let's see how many of you guys got it in the first sight. I'll give you 2 minutes. First person with the right answer gets a credit. So, last call. Let's do this together. First thing, don't rush. Just put this down. What do you understand from this notation? Put it into symbols. I see 2 machines. The outside machine is G. Final machine is G. There is a machine built inside this outside machine, which is F. So F is going into belly of G. So F needs to be computed first. Like your wheat is used up by F first. Consume the wheat in F first. So take F function, use your wheat in it, and get this product x plus 6 and put it there. So we always start inside out. Inside is f of x. All you need to do is copy paste. Copy what you have into here. It's that easy. Step 1 is no brainer. Don't make it any harder. Copy what you see in the inside from the formula given. Move. Okay? Next, this is the challenging part. Here comes the main function g. So you need to take a close look at how it works. It takes everybody inside, square it. Look, if you see x, it squares it, multiplies by 4, and then adds 5 times that stuff to itself. Okay, so I will copy this formula right here because that's what it does. This is what g does. I will copy it here, except one thing different. I will empty out x's. Why do you think I'm emptying out all x locations? Why do you think? Because I no longer see x here. Do you see only x here? Do you see x? Do you only see x here? No. There is more stuff here. Since it's no longer just x, I wish it was just x, then I would copy this entire thing and we'll be all be done. It's not just x, it's something else. I empty all the spots in g with x's. And guess what I'm gonna fill them up with? What am I gonna replace them with? Yeah, whatever I see here will go replace there. And always, this is the lesson we got in this class, in the previous problems as well. If you are bringing back more than one item in place of another single item, there used to be a single x here, you're bringing back twice to two items, x and 6, you must use a parenthesis there, sir. Even here, use a parenthesis. And whatever you have around that parenthesis, you must distribute it into those terms. So this square must be passed into x and 6 the right way. I'm gonna do the wrong way. See what is wrong. Mostly you guys think the square is just passing inside just like this, x squared 6 squared, right? Do you think that way? The right way? No. But you square a sum. This is a sum of square by foiling it. So you guys really take your time. Take your time here and square this nice and slow by foiling it. This is x plus 6 times x plus 6. I FOIL first terms first, x squared, outside terms 6x, inside terms 6x, right? And then last terms, which is 6 times 6, 36. That's how I FOIL it. And then I will this 4 in to everybody, and this 5 to everybody, so it is 5x plus 30, and we will be done. By the way, some people like to add this first, then pass 4 in. It's okay, because this is 12x. When you multiply by 4, it makes 48 of them. Or you do it later. 4 times 6 is 24. 4 times 6 is 24. Add them up, it's 48 again. Either way is fine by me, but the other terms needs to be just taking 4 in. 4x squared. 12 times 4 is 48. 4 times 36 is 144. 5x and 30. And finally, we add like terms. There is nothing like this square, so copy it. But these are like, right? They are like. So they make 53 of them. And these are like as well. That makes 174. Alright. The closest answer is the first one, but that's not right. You're missing a digit here, 53. Okay? Makes sense? I'm kind of scared nobody got the right answer, but It was just the first example we did, so I'm okay with that. But now you know how this works. Again, what did I do? Basically two body in the solution part. First, copying, just simply copy this thing here from the formula. Second is replace in G formulation, replace each and every x with this copied item. And FOIL multiply, that's it, combine like terms. The rest is regular algebra you've been doing whole semester. But here is the replacement part is probably new. Okay, don't worry, we'll do more. H circle K. Two new functions. This is over. We have brand new two functions. Circle H and K. H is out, K is in. This is easier than the previous one, so I'll give you a minute. Yes.
1 over x squared plus 7.
1 over x squared plus 7 is our first response.
No, the plus 7 is still on the bottom.
Okay. This?
Yes.
Okay. Next. So you said 1.
Just 1x squared plus 7.
Okay. Any third answers? Okay. Now, first off, H circle K means H is outside, K is going in, and operating on X first. So the width is going and visiting the K machine first. All you need to do is read what K does from the formula. K of X is 1 over X and replace it. Okay? Next, at this stage, H is operating. The operating machine is H. So forget K machine now, it's over. Focus on the formula of H. Copy its formula right here, except instead of X's, empty out the locations with X's. We're gonna bring in new stuff there. That machine is no longer taking X in, it's taking 1 over X in. So you're gonna make this 1 over X. So the result is 1 over X squared plus 7. However, there is a way you can pass a square to quotients or ratios. You can pass to the top and bottom separately and make this 1 square over X squared. But what is 1 square? What is 1 times 1? 1. So the second answer is actually correct, okay? Alright? So what is the mistake? I see some mistake here. This is, if you do K circle HX, this is what you're gonna get. So where is the difference here? This is H is out, K is in. The K is in, H out. Here H is going first, K is out. So your width is first visiting bread machine, then visiting grinding machine. Reverse order. Reorder differs because you get a quite different machine there. Okay? So if they ask K of H, you will supply the first answer, but the correct answer is the second one. So let me see the other parts. What is asked on the other parts? Here first we try 1 over X squared plus 7. Yeah, in the second one, they're asking for restrictions. Are there any values that makes this function undefined? 1 over x squared plus 7. Can you choose an x value and this function is not computable? Are there any such values? You may think no, but there is actually one value.
Put 0 in there, wouldn't it?
Yeah, 0 is this time bad because there is nobody to save this guy next to it. It doesn't have an 8 this time to move it up to 8 value. Is x squared is alone. If you substitute x equals 0 there, 0 squared is 0, 1 over 0 is undefined. So there is a restricted value. It has one restriction, which is 0. If it becomes 0, we are in trouble. So we list that in the statement. Oops. Oh, we need to say x is different than 0. It says when this function is valid, it's valid if x is different than 0. If we choose 0, we are bad. It's a bad value. So we need to choose inequality, not equal sign. Alright, brand new question. Try it. Look, I mean, there is no new trick. It's pretty much the same thing again. Wait a minute, is it the same question?
No.
No, it's a little bit different. And the order is different. Order different this time. K is first, H is second. Yes.
So this one, the 1 over x squared plus 3.
Right, this one is the 1 over x squared plus 3. Something wrong with my computer today. But others, please try. Take your time. Do the same steps. K is first. K is outside, I'm sorry. H is going in first. So one answer, this is already correct answer, okay? Well, how did we get it? Again, K, Hx is what this reads as. We first copy H here. What is H? Right here. X squared plus 3. Then we're done with this. Go to the second one. And the second one, empty out all spot with x's. Oh, good news, it's only one spot. So empty it out and put what back in? This is it. X squared plus 3. And we're done. We're already there. So after a few trials, it just takes 20 seconds to figure out this question. So it's not a big challenge, okay? But you need to pay attention. The order is missed most of the time, and replacement part is confused. So you need to practice. Okay, in the remaining questions, there are a couple left. There is a change. Change is we are just dealing with numbers now. No more x's. Do you see x here? No, instead a number. So how does this change? Let me compare this to old version. In the first, second, and third questions in the homework, we used to have x. So this is what you worked on. You put an x and mx and you subtracted them, right? You no longer have x here. Instead you have 1. So guess what I'm gonna do? If you don't see x there, then wipe off all x's and make 1 then. That's it. I see 1 here. I'm making 1, 1, and 1. Again, this is just a subtraction question. This is not composition anymore. Alright? In subtraction, you need to compute the first, compute the second, and subtract. Now how do I compute n of 1? N of 1 is, how do you do that? No, it's not just, this is not multiplication. It's not n times 1. This means 1 is processed by n. You need to put 1 in processing into machine, supply 1 to machine and compute this. N of 1 is replace x by 1, which is 1 minus 8. It gives us minus 7. M of 1 means 1 instead of x, 1 is processed by m. It's just replacement. It's 1 cubed. 1 cubed is 111, which is 1 again. 1 times 1 times 1 is 1. You don't need a parenthesis or something. It's just a single number. So you're safe here. And you just need to combine negative 7 and negative 1. They make negative 8. That's it. I wonder what is asked. It's probably second part, but let me check what is asked in the first one. It just says if you can compute and get a number result. Yeah, we got a number result. And what is that number? Negative 8, right? Is that so? Okay, that was an easy practice. Number 9. Oh, we are back to our nightmare again. It's composition. They want us to compose 2 functions, but this time instead of x we have a number. So how is it different? This means same deal. You put m machine inside, but we used to do it with x's earlier. You don't have x here. What is it? You have mo1. Yeah, 1. In 2 minutes ago, we used to copy mox here. You would just copy it, read and copy mox to here. You're no longer not be able to do that. Why? Because this is not mox, but instead it is mo1. So all you need to do is plug in 1 and copy the result, which is 1 cubed is 1. Do you get it? Again, we are doing pretty much the same work, but instead of x's, taking this with x's, replace x by 1 and take it. When I replace x by 1, this is 1 cubed, it's 111, 111 is 1. Next, we need p, but they have give p us with x. I need p01. p01 means replace 1 here. Take p, empty x's out, but instead of x, I have 1. So this gives us 1/5. Yeah, we got a real number. Sometimes you don't get, because it becomes undefined, and that's 1/5. Okay? Alright, the next question is for you, because it's not any harder than what we just solved. You're going to compute a addition of two functions, addition only. So you enter -2 in n, you enter -2 in here, and you will get something surprising. What do you expect to get? Let's do it quickly, because that's an interesting question. N plus p of -2 means you compute -2 in n, add, you compute -2 in p. Alright, -2 in n means plug in -2 here, right here. Plus, plug in -2 in p now. P says, p is taking -2 in, plug it in. And tell me what's going on here, please. This becomes 0. Can you guys compute 1/0 and add some stuff to it? No, this is entirely undefined. So you cannot compute this thing. It's not a real number. So for the first time, we end up with something non-zero. Well, how can they expect an answer from us? They can't. It has to be an undefined answer. Okay, so this is it for 8.4. We'll continue tomorrow, okay?